Hello everyone, this is homework number 2 for the 6 weeks. Its title is Transcription and Translation. It's going to be due on Thursday, October 23rd. I found this fun little quote over here and I wanted everyone just to take a minute to read it. It says, "There is no end to education. It is not that you read a book, pass an examination, and finish with education. The whole of life, from the moment you are born to the minute you die, is a process of learning." And I just thought that was a really beautiful quote, especially as we're sitting here about to learn about transcription and translation. So, something to keep in mind that this is a process for your whole life and will benefit you forever. So, the essential question for today, there are actually 2. It says, how do transcription and translation occur in the cell? The second one is, what is the purpose of these processes? So the standard we're focusing on is B6C, explain the purpose and process of transcription and translation. Very similar to our essential question. So today in class, a lot of you should have learned about transcription. You got the background of transcription. You probably watched a video about transcription. So today we are going to recap this information about transcription and we are going to introduce translation. And then tomorrow in class, you're going to hear more about that. So today in class you learned about the central dogma, right? You saw that DNA turns into mRNA or produces mRNA. This happens by a process called transcription and it occurs in the nucleus. We know it has to happen in the nucleus because that's where our DNA is located. And RNA is produced from this process of transcription, and we'll talk about that in a second. So, some of the big ideas from today on our lectures about transcription. So you should be taking notes on this, even though it's a review, it would be good for you to still take notes on it. So transcription is the first step in making a protein. So it occurs in the nucleus. And DNA makes mRNA. So that is the goal here. That is what's happening. mRNA is what gets sent out of the nucleus, okay? And it is one gene, a small part of DNA that codes for a protein. So these genes, these small pieces of DNA are going to code for a protein one at a time. So you also saw this today. What's the point? Well, the whole point of this is that because of DNA and mRNA and what we're going to talk about today being proteins, we get something called gene expression. Gene expression. And this is when our genetic information, our DNA, okay, let's just make that clear, our DNA is turned into something useful, one section at a time. So our DNA is awesome. It's great, but it doesn't actually give us blue eyes, if you will. It doesn't make your blue eyes. Proteins make your eyes blue. DNA just says, hey, this person's going to have blue eyes. So something important to keep in mind is that the whole point of this, the reason this is important is because DNA tells us what genes or what traits or what characteristics to have, but this mRNA and these proteins, they actually make those things happen. Okay, so you saw it today to be thought of like this, that DNA is the master blueprints and that mRNA is partial instructions. So it's just pieces of the blueprint. So this is a big thing to focus on, and you saw this today, so I won't spend a ton of time on it. But one thing I do want to highlight is the fact that both DNA and RNA end in NA. And I know that sounds silly, but the reason that's important is because we need to realize that DNA and RNA are both nucleic acids. They're both nucleic acids, meaning they are both biomolecules. We've talked about those now for like a month, okay? And so they are essential molecules for living things. And so just like a protein, a carbohydrate, and a lipid are essential to living things, these nucleic acids are also essential. Okay, and so living things are going to have DNA, they're going to have RNA, and so something just to keep in mind. Okay, so the 3 major differences that you need to remember, okay, is that RNA has ribose, fairly simple to remember because of the R's, right? It's got ribose instead of deoxyribose, that's why we call it RNA. RNA is single-stranded, so if you look over here, it only has one of the backbones instead of 2, like DNA does, okay? And RNA contains our uracil base, our U, Okay, it contains U instead of T, and that's what you see over here. Okay, over here we have our U base now, right here, instead of this T in DNA. Okay, so something to keep in mind. You do have to know those three differences. Okay, so now back to the central dogma. We are experts, I'm sure, on transcription. We know that takes DNA and makes mRNA. We know that it happens in the nucleus, okay? The next step we need to focus on is this one right here, translation. Okay, translation. This occurs in the ribosome, and you're going to see that the main purpose is to make a protein. Okay, so let's talk a little bit about how that happens. Okay, so let's get a little definition here. So translation is when mRNA, right, what we start with, is decoded to make a polypeptide. And if we remember from our biomolecules, a polypeptide is simply a protein. Simply a protein. Okay? This occurs in what we called just a minute ago the ribosome. So the ribosomes are the organelle. Remember, that just means the little organ. So the nucleus is an organelle. The cell membrane is an organelle. Okay. Ribosomes are the organelle where translation occurs. So that's where this happens, okay? Sorry for my handwriting. It's pretty terrible today. So as we're looking at this, okay, we notice a difference here is that we start with mRNA and now we make a protein compared to transcription, right? And another difference is that it occurs in the ribosome. So that means, okay, that this doesn't happen inside the nucleus. We have to leave the nucleus for this to occur. So what is leaving the nucleus? Okay, if we notice this right here in this diagram is the nucleus. Here's our DNA. Here's our mRNA that was just made through transcription. And you'll see that if mRNA is pink, mRNA is what's leaving the nucleus, finding my ribosome, and making my protein. Okay, so mRNA, the answer to this question is that mRNA is what now leaves the nucleus. DNA will never leave it. mRNA is what's going to leave. So, brief overview of what happens in translation, okay? And you're going to see something similar to this tomorrow. So, in translation, the very first thing we see is that mRNA travels to the ribosome. So, again, as we just said, mRNA is going to leave the nucleus and head to this organelle called the ribosome. So, in this ribosome, okay, this is where something called tRNA or transfer RNA is going to meet our messenger RNA. So tRNA is going to meet mRNA in the ribosome, and it's going to bring the right amino acid to the ribosome. So if we remember, amino acids are the monomers of proteins. And so we are bringing the small pieces, the building blocks of a protein, okay? tRNA is going to bring it to the ribosome, and then the ribosome is going to help it build these amino acids and put them together. Okay, so this translation thing can get a little confusing. So let's step back and think about it in terms of something we all know and love, the vending machine. So if I walk up to a vending machine and I want to eat, let's go with Doritos because Doritos are amazing, okay? I want to get Doritos, right? How do I get my Doritos? Well, I look at this number and I plug in the code. I plug in B2. That tells the vending machine, okay, that I want Doritos. And so what's going to happen next? Well, these little spirals over here are going to carry my Doritos to the end of the shelf. And they're going to let them go. They're going to dispense them down into the drawer so that I can pick them up and eat a snack and be happy, right? So I enter a code, B2. The spirals on the shelf carry my snack, carry my lovely Doritos to the end of the shelf. And then my Doritos, my product, falls and I can pick it up. So now let's turn to our mRNA, tRNA, and amino acids. So our mRNA in this situation, our mRNA is our code. It is our B2. mRNA tells the cell, what amino acid it actually needs. Okay, tRNA is going to be our spirals. It's going to be the spirals that carry that final product, that cheesy goodness of Doritos, to the end of the shelf. Okay, our tRNA is going to be in our cell what carries our amino acids to the mRNA. So it listens to the code of the mRNA, matches it, and brings the amino acids just like these spirals bring the Doritos when I plug in B2. Okay, then the amino acid is the Doritos. It's the final thing that I want that's going to build my lunch or build my protein. So these amino acids are being carried by the tRNA, and they're going to be connected in the ribosome to build my protein. So let's get a little bit more scientific with this. Our mRNA is read in groups of 3. So this code, okay, of mRNA is read in groups of 3 bases at a time. So whether I'm talking about my A, my U, my C, or my G, it doesn't matter. It's read in groups of 3, okay? This group is what we call a codon. A codon. So it's a codon, okay? And it's made up of 3 of our bases. So down here might help you a little bit. 3 RNA bases equals 1 codon, and 1 codon codes for 1 amino acid. Codes for 1 amino acid. So it's like a code, okay? Our code is 3 of our RNA bases, and it gives us a codon, and that codon tells us what amino acid we need, okay? So for every 3 bases, we get 1 amino acid, and we just call that 3 bases a codon. So how in the world do you know which amino acid each codon codes for? I mean, there are over 20 amino acids. How do we know, and there are so many combinations of these bases, how do we know what it codes for? Well, thank goodness for scientists, because they made up a codon chart. And yes, you have to know how to use one of these. So let's look at the one on the left first, this guy right here, okay? This is the one you're probably going to see most often. I know it looks confusing, but it's actually fairly simple. So let's say our codon, which is our 3 RNA bases, I'm just going to make one up. Let's say it is GAC, okay? GAC. Well, I look over here and I say, okay, here is my first letter. So what is my first letter in my codon? It's G. So I'm going to start right here, okay? I'm going to put a little star there so we know where I'm starting, okay? I'm going to start in that box, okay? Then I look up here and it says second letter. Okay, well, what's my second letter down here? It's A. So I'm going to look up here and I'm going to find my A box. Well, there it is, okay? I'm going to come down and I'm going to come over. And I'm going to find that all of these hit one boxed area, right? I'm going to find where these overlap. Because what do you think I'm going to do next? I'm going to look over here and I'm going to find my third letter. Okay, my third letter. Well, there's 4 options for your third letter. There's U, C, A, or G. There are many possibilities. So all you do is you look over here on your third letter and you find where does that last one intersect, okay? And it intersects at aspartate, okay? That is the name of the amino acid that GAC codes for, okay? So you start on the left, find the first letter, then move to the top, find the second letter, go to the right, find the third letter, and see where they all come together. And that box tells you the amino acid that it codes for. So now let's take a look at the one on the right, okay? This is called our codon wheel. I find it to be way easier than the codon chart, but to be honest, you have to know both because you could see both on any given test or assessment or anything like that. So let's use our same amino acid code right here. So let's use our same 3 RNA bases, okay? The thing you need to know on this circle chart, okay, on the codon wheel, is start on the inside and go out. Okay, start on the inside and go out. So what is my first letter again? It is G. Okay, it is G. So I'm going to start right here. And I'm going to go to my second letter. My second letter is A. So I'm going to just follow it out. A. Okay. Sorry for that announcement. Okay, so again, I start with G, okay, and then I just move out to my second base, which is A. Notice there's lines here. That means I need to stay in this box. So I can't go from here over to here because there's a line there, okay? So I'm going to start with this G, and I'm going to go to this A, and then I look and find that my last letter is C, okay? And I can't cross over these lines, remember, so I need to stay in my lines, and I'm going to go to C, which is aspartic acid. And just so you know, aspartic acid is the same thing as aspartate, okay? They're actually exactly the same. So just FYI. So let's say, for example, if we did another one, we could do, let's see, GUU, right? So if we did GUU, if that was our codon or our three bases, over here I would start with this G, okay? I'd go to this U, and I'd go to this U, and I'd find where they'd all intersect, and that would be valine, okay? If I come over here and do GUU, okay, I start with this G. I have to stay in this box because I can't cross over the lines. I go to this U, and I go to this U, and I find that it is valine again. Okay, so whichever chart you use, you should get the same answer because it should code for the same amino acid. So here's the debrief, the practice for you. You're going to get plenty of practice in class as well, but I want you to do this and show it to your teacher tomorrow so your teacher can help you out and kind of see what you need to understand. So it says, transcribe the DNA strand below into RNA and then use the codon chart to translate it. So there is your beginning DNA strand, TAC, ATC. Okay, you need to transcribe it into RNA. What would this be in RNA? Okay, and then you need to use your codon chart over here to make your amino acids. All right, so you only have 2 groups of 3, so you're only going to have 2 amino acids because remember, a codon is only 3 letters. So good luck, show it to your teacher, and rewatch this video if you need any help.